Hypothalamus Artificial Intelligence, HI. Digital transformation powered by real-time autonomous and intelligent algorithms. Presents the short conference, Autonomous Real-Time Robots Communication. It corresponds to one of several short conferences, in which the advances of HI research are presented, on the topic of artificial brains and decision-making artificial intelligence. The list of short introductory lectures to decision-making artificial intelligence are presented in the picture. Conference prepared and edited by Jesus Velasquez Bermudez. His resume may be found on LinkedIn. The central part of an artificial hypothalamus is the formalization and the standardization of a math language between cognitive robots, to be used as the way to communicate multiples math algorithms. The core of this language is the duality theory, that support the mathematical programming algorithms, that may be developed using the concepts of large-scale optimization methodologies, to solve high complex math models based on the partition and the decomposition of the real-life complex systems. An artificial hypothalamus corresponds to a superalgorithm that coordinate multiple cognitive robots that operating simultaneously, autonomously, in real time, acting as the human hypothalamus, to achieve a common goal. By joining all the concepts presented here, it is possible to define a language between robots, math problems, algorithms, or agents, based on an exchange protocol of information between the multiple types of problems, in which any pair of robots communicate by exchanging the information produced by each of them, which is synthesized in the value of the primal and the dual variables that they produce. If each robot is identified by the R index, in each conversation step K, the actions of each robot are inputs, dual and primal variables that our robot uses produced by other robots. All the data available until the begin of conversation step K is characterized as the historic knowledge database QK. Outputs, primal and dual variables that produce the robot R, it can be characterized as XKR, PKR. Transformation function FRQK, mathematical problem that the R robot solves to produce XKR, PKR, starting with QK. Mathematically this is XKR, PKR, equals FRQK. QK equals QK minus 1 union with XKR, PKR, Q0 equals. When our robot receives information QK, it processes it, generating information, XKR, PKR, and a conversation step K plus 1. The robots receive, or search, the inputs produced by other robots, and produce the outputs to be used for other robots. The information produced is added to the historical, and it is stored in the artificial hippocampus, an intelligent database on disk, or in RAM, which can be accessed in the next conversation of all robots. Then, based on large-scale optimization methodologies, communication between robots is synthesized in the transformation functions FRQK and in the storage of all the information produced, XKR, PKR, in an optimization knowledge database, QK, which can reside on RAM disk, offline, or on RAM memory, online. In a static problem, frontier conditions fixed, when the coordinator robot detects that has enough information to establish the optimal decision, it proceeds to close the conversation cycle, and terminates the optimization process. If the problem is dynamic, frontier conditions time-dependent, the robots will have a continuous conversation in order to keep the system as close as possible to the optimal decision path, which is not possible to obtain due to system uncertainty. This process, based on duality theory, is the support of artificial hypothalamus capable of processing the information required for Industry 4.0. Alice, which way I ought to go? The Cheshire Cat. It doesn't much matter which way you go, if only you walk long enough. Thank you for your attention.